Hi, good morning. So my name's Ed Schofield, and I'll be introducing this day. So first of all, welcome. Thanks for coming. So it's very exciting to have this that we're organising for the first time as part of PyCon Australia to have a science and data day. So we've got a full program of talks, and it's going to be very interesting. So it's a privilege for me to be able to be introducing this today. Okay, so first of all, some general information. I suppose the most important point that the conference organisers have asked me to say is the dinner reservations are up on the wiki. So if you'd like to go to dinner tonight, then please reserve there, and there'll be tables reserved for dinner. Next, there's Wi-Fi details there. They're also up here on this whiteboard. Okay, and lunch won't be catered, but morning tea and afternoon tea will be. Okay. Okay. So I thought I'd say a few words about Python for science and data analysis in general. So we all know, well, I suppose many of us will know that Python's origins came from a teaching language in computer science, and it's actually 23 years old now. So it's no longer the new kid on the block. And there've been a steady stream of releases every 1 to 2 years, and it's been getting better. And the adoption's increased so much that by now Python is actually the most popular teaching language in US colleges. Okay, this was from an article in the Communication of the ACM just this month. Okay, so it's actually overtaken Java as the most popular teaching language now. Okay, so how has Python grown like this? So I think there are a few factors. One is that it's readable, so even occasional programmers can grok it, and it's open source and portable across many platforms and so on. And one of the factors for science and data analysis in particular has been that it's easy to create C extensions, and NumPy is the most well-known of those. But there's a whole ecosystem of science-related and data-related C extensions that extend Python from being a general-purpose programming language to one that's really good for handling data analysis. Okay, so and the syntax of the Python language has been so it's been extended in a few instances. So, for example, overloadable operators and support for multi-dimensional indexing, which the features that were requested by the science and engineering and data analysis communities, and Guido and the core developers have been accommodating in allowing Python to expand to become a language that's well suited at the syntactic level. And syntax is important. This is an article from 2007. It's an example of the kind of sort of push that Python's had in the field of science and engineering. Okay, so NumPy is the foundation of a lot of scientific work in Python, and the origins of NumPy go back to sort of the mid-90s. And this is from a keynote given by Travis Oliphant, who's the principal author of NumPy at EuroPython, which was just 1 or 2 weeks ago. So SciPy had its origins around the turn of the century. It really came together from 3 people initially. So Travis Oliphant, Eric Jones, and Piru Peterson. Combining different tools into what was really a distribution at the time. We didn't have package management tools as good as we do now in Python. So SciPy was a kind of distribution of lots of packages, which otherwise would have been hard to stitch together. And then there's the fact that the community's really been growing, and this is showing the number of commits to each of these 3 projects, NumPy, SciPy, and Matplotlib. And interestingly, this is the advent of GitHub, and the collaborative development opportunities that it makes possible have really allowed these projects to grow enormously, and same with others as well. So this is one factor. The communities sometimes things can kind of come together like useful tools to allow the community to really take charge and really contribute massively to projects. So I suppose the scientific Python ecosystem is very big and very broad and diverse, and NumPy in some sense sits at the middle of it in that it's a transport layer for data. But yeah, there are many tools, and it's getting better all the time. So it's an exciting time to be involved in Python for data analysis and science and engineering. And it's in some ways, in quite a lot of ways, Python is now leading the way. So many languages now have access to the IPython notebook, for example. But it came from Python. But it's been expanding beyond that, sort of changing the definition of what people think of as a sort of the way to work for many sort of scientific type problems. Okay, so yeah, the IPython notebook is really a game changer, and that's only really been around for perhaps about 2.5 years or so, since Euro SciPy 2012, I think it was announced. So yeah, pretty recent as well. But it's probably something that most of you have probably used or at least seen it, and I'm sure you'll see a lot of it today. Yeah. So in the talks we have today. And then there's this survey which was done recently, so at the O'Reilly Strata conference, on different tools people were using for data analysis. So Python is right up there. It's behind R on this scale, but above Excel even, at least among attendees for this conference. So it's interesting to see that Python has such a foothold in data analysis in general. That's very interesting too. And this is rather new, I'd say. I suppose the field of data science is rather new in itself, but Python is really leading the way here. And then we have various areas that Python's growing in too. So Python's already very strong in geospatial analysis, both with proprietary commercial tools and solutions and open source packages as well. And Python's really growing in finance and economics. The first talk we have this morning from Arthur on Monte Carlo simulation for business case analysis. I think something like that. So yeah, that'll be interesting. And so Python's been growing in that field primarily because of pandas. But yeah, it's really growing there. So, and big data in general is Python's really helping to make the most of this sort of new wave of problems where data has mass and code has to sort of flow through the data, which is pretty hard to do with proprietary languages where there's a license fee might have to be paid for each individual use of it. Whereas in Python, because of the open source nature, that's possible a lot more. And there are various other new fields that Python has is taking hold in, and some of these fields didn't even exist 5 or 10 years ago. So data-driven journalism is a field that is growing. So it's a form of social science in a way, but the idea is that the research into articles can actually be made publicly available and subject to the same kind of peer review as scientific papers. So please come in. And political science too, and economics are all becoming more quantitative, and many people have working in those fields aren't programmers and aren't computer scientists, and they want a language that's simple and easy to learn, and Python fits that bill really well. Okay, so I think there are a lot of reasons to be excited, and I'm looking forward to today and to meeting many of you. And with that, I'd like to introduce the first speaker, Arthur Street.